which reagent would be used to convert an alkene to an epoxide? So let's say we have this alkene ring structure right here. The epoxide would look like this, where both carbons from the alkene are bonded to the same oxygen, and these bonds are going to be on the same side, either both dashes or both wedges. Now, the reagent that causes this is something called a peroxy acid, and the general formula for peroxy acid is this RCO3H, okay? This is kind of what it looks like right here. As you can see, it looks like a typical ester or carboxylic acid, but now there's an extra OH. This O to O bond is really weak. We're going to talk about that later. But which of these fits this criteria? The answer is going to be B, because this is metachloroperoxybenzoic acid, which looks like this. It's going to look, this is really bad drawing, but something like this. This is like your peroxy acid part, and this is like your R group and whatever. So this is something you just have to know, but we're going to talk about like why this even occurs with the peroxy acids. Here's our alkene and here's our peroxy acid. It looks a little different, but I just oriented it differently. It's the same thing, however. This R group can be whatever, for the MCPBA it was this thing, right? The chlorine or benzene thing. But the main aspect is this part right here, right? We have the carbonyl with the OOH. And once again, this O to O bond is really weak, and you'll see why it plays a big role in this. And so essentially what happens is this double bond bonds to the O, and this bond from the oxygen bonds to this carbon. And then this bond between two O's breaks, comes here. Now this H is by itself, right? This bond went towards this carbon, so this H is by itself. So one of the bonds from this double bond O comes and bonds here. Now look at what we end up with. I oriented it the exact same way, right? This O was single bonded, but now it's double bonded. And this O was double bonded, but now it's single bonded with an H, okay? So we ended up with a carboxylic acid from this. This is a really good molecule. And look over here, we have our epoxide. Now, keep in mind that these two are going to be the same, right? If we're bonding to one molecule, you can't have a dash and a wedge. You can't bond from the front and the back to the same thing. So they have to be from the same side. So either both dashes or both wedges. Once again, our answer choice is B.